Hello everyone, it's Mr. Ray here. We're going to continue on with our grade 12 data management course. We are in Unit 4, Statistics, and we are today going to look at measures of central tendency. These are some terms you probably heard earlier on in your math careers, things like mean, median, and mode. They represent basically we call it central tendency, or you could think of it as the middle mark or the average mark or the most common mark. Those all mean different things. Sometimes they're exactly the same in numbers, sometimes they're completely different. So we're going to look at those. So the mean is basically a more common word for mean is average. So basically what you do is you add up all the values, your data entry values, and divide by how many of those values you have to get the average. We also have a slightly different version of mean called weighted mean, where you can apply a weighting factor to each of the types of data entries. So we'll do an example on that later on in the lesson. The median is the middle mark. So if you arranged all the data, all the numbers from your data, and it doesn't really matter, ascending or descending order, and you find the exact middle value, and that is called your median. Okay, and then the mode is the most popular, the most common value that appears in your data. More often than not, it's usually around the middle or your average, but it definitely does not have to be. And you can also have more than one mode. You can also have 1 or 0 modes. So in terms of the three measures, mean, median, and mode, definitely the mode is the least valuable, but sometimes you will be asked for it, so make sure you know how to get it and what it means. We also have something called outliers. An outlier is an element of the data set that you've gathered that is significantly different from the rest, meaning a lot lower or a lot higher. So you'll see that these outliers have a greater effect on the means, the averages, than on the medians. So we'll look at that as well later on. We've got talked about the three measures. The average is the mean. I've got these two formulas here. I want to introduce you to a couple new variables. So if I was taking the mean / average of the entire population, which usually doesn't happen a lot, we have this new symbol here. It's a Greek letter, and it's pronounced mu, kind of like a cat noise. So I'll just kind of spell it out phonetically, mu. So it's just adding up all the data, all the numbers in your population, and dividing how many are in your population. And we also have a sample mean. So this is population, your entire population that you're interested in. This is the sample you're taking. We have this variable. It's an x with a bar across. So obviously we're going to call it x bar. X bar. That's the way you'd pronounce it. And it looks like exactly the same formula. All the values of your data set divided by how many you have. But you notice we have a little n, which is the sample size. A capital N is the size of the population. So there's really not a big difference in the formulas. One is for sample, one is for population. Where it's going to become more important is in the next lesson when we look at the spread of the data. We will be using these two values separately. So it's important to understand what they mean, not so much for today's lesson, but for the next lesson. Okay, now the median, we've already talked about it. It's the middle number when the numbers are arranged in order. Now, if you have an odd number in your data set, such as, well, let's go a low number, say we had 7 in your data set. Well, in that case, the fourth would be your middle value, the fourth number in order. You have 3 above and 3 below. So when you have an odd number as your n, as your number in the data set, it's the middle value. Now, what happens when you have an even number? Say you had 6 in your data set. Well, if you try to find the middle value of 6, it's like 3.5. So what do you do for that? Well, you actually combine the two entries, 3 and 4, and find the average of those two. That becomes your median. Okay, so sometimes you use a number that's already there, and sometimes you take the average of the two middles. So it depends on whether it's an even number or an odd number of elements in your data set. So we'll look at doing that later. Talked about mode earlier. Outliers can have a big impact on your stats. So sometimes what we're going to do is ignore them, because sometimes an outlier can be maybe the data was incorrectly written down or measured. Sometimes it's actually real, but you almost discount it because it's rare and it can affect the data. So and then the weighted mean was where we apply a weighting factor to each of the values. We also have group data. We're going to do an example of that. So we'll talk about that when we get to it. So we have a formula here that looks a little intimidating. Don't worry about it yet. Okay, so let's do some math here. We're going to calculate the mean, median, and mode for, we have 2 classes that wrote a physics exam on the same day, or the same exam, and we had the following results. So we had class A, class B, and these are the marks for each class. Now, unfortunately, these marks are not in ascending or descending order. They're fairly random. Now, that's not so important for the mean, because the mean, we just add them up anyways and then divide by how many are there. But it is really important for the median. We have to find the middle mark. So we're going to have to resort these. It's also important for the mode because although you don't have to have them sorted, it certainly helps to find the most common ones. Okay, so what I'm going to do here, determine the mean, median, and mode. So I'm going to start with class A. And we do need to know how many are in there, and there's 17 students in that class. So I'm going to say n equals 17. And then I'm going to list, I already created this list earlier. I'm sorting them from lowest to highest. So I have 45, 51, 55, 64, 66, 68, 70, and then I have 3 71s, and then 73, 76, 82, 83, 84, 90, 95. Excuse me. Okay, so for the mean, now I'm going to call this a sample. It's a little ambiguous sometimes. Do we consider this to be a sample or the population? Well, I'll call it a sample because it's not all the grade 11 physics students, so we're sampling them in each class. So the mean for a sample is x bar, and what we do, I'll use a new notation here. We use this sigma letter. Of course, it's another Greek alphabet. Sigma means add all up the values of x. So x meaning all the marks. And then we divide by how many marks there are, which we've already said n is 17. So all that means is this plus this plus this plus all of these. So 45, I'm not going to write these all out, don't worry. 45 plus 51 plus dot 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 plus 95 over 17. That is equal to 1215 over 17, and that's equal to 71.5. So that is the mean of Class A. Now for the median, which I'm going to do next, I'm going to show you a little formula here that's very helpful, so you don't have to figure out where the middle mark is. Well, you do, but you do it through a little math formula. So for Class A, we find them, we call it the median position. Okay, so that will be how many entries in is the median going to be. So the way we do that, and we're going to see this formula in the next lesson as well for some other purposes. It's n plus 1 over 2. So we take the number of students in the class, which is 17, add it to 1, we get 18 over 2, which is 9. And that says that we can find our median mark in position 9 of the sorted data set. So here we go, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is our median. And like I said before, since there's 17, which is an odd number, we will get an exact position, a single position, to find our middle mark, our median. So we can say our median is 71, and that's pretty close to the mean. And then our mode is the most popular or common mark. And it's beneficial to have this sorted as well, because I can see where I have doubles or triples. So far nothing. And I see I got 3 71s, and that's the only one. So our mode is also 71, because we have 3 of them. So we're going to analyze this on the second part, but let's continue on with the second class, Class B. So Class B has 18 students, so n is 18. And if I sort that data, you'll see got a couple students that didn't study very hard. And then 44, 50, 54, 61, 63, 69, 73, 74, 75, 80, 80, 81. Oh, I think I left out one of the 61s. There's 2 61s, there's 2 80s, 81, 84, 91, 92. Okay, so that should be all 18 now. So for the mean, same formula as Class A. It's the sum of all the x values, all the marks, divided by this time 18. So I'm just gonna, I'll just go to the final number here. You know how to calculate now. That's 64.4 is the mean, so lower than the other class. The median, so first we have to find the position that we're looking for. So I'll do that up here where I did the other one. So this time the median position, still n plus 1 over 2, but this time n was 18. So I have 19 over 2, which gives me a 9.5. So what does this mean? Move this over a bit. That means what, if it's an odd number, you'll always get like a decimal here. So what you do is you take the 2 integers that surround that decimal. So in this case we do 9 and 10. Okay. So in this case we find our 9th and 10th marks in order here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 69 and 73. So this time I'll put them in my formula. 69 plus 73 divided by 2, and that's equal to 71. Okay, you don't always get an integer, but we did this time. And then the mode is the most popular marks. And like we already saw, we have two 61s and we have two 80s. So there are two modes this time, 61 and 80. And you can tell, they're quite far apart. It really it's all kind of random chance as to where they might be or might not be. Sometimes you won't have any mode. If they're all the same, if they're all different, you say there's no mode. But you can have two or three, just like we have two here. So it's all random chance, and it doesn't mean a whole lot. Okay, so let's go down to the next part. Use the measures of central tendency to compare the performances of the two classes. Okay, so if I look at the median marks, you can see they're exactly the same. We should underline them. So the median marks are the same. Exactly the same. Now the other ones aren't. But the thing I noticed, class A, we had a 71.5 for the mean, 71 for the median, 71 for the mode. Very, very close. It's almost rare that it would be that close. So the mean measures for class A are very close. And when I say the measures, I mean mean, median, and mode. But not for class B. Because class B, well, 64.4, 71, and then our modes are, even the modes are quite far apart. So not overwhelming in terms of consistency there. Also the mean, this might be the thing that a teacher would look at first. What's the average for the class? 71.5 versus 64.4. So you'd say sorry about that. The mean is for class A is higher. So those are probably the three things that I would talk about in terms of comparing the marks. Okay, and then the last part, what is the effect of any outliers on the mean and median? So if we look at the sorted values, so the things you're looking for is, are there any numbers that kind of stick out as being really low or really high compared to the rest? And for A, I'd probably say there isn't. Okay, obviously you have a high and a low value, but they're not that far off the next few that surround it. So I wouldn't say that there's any outliers for class A, but for class B, as I mentioned earlier, the 12 and the 15, they're quite noticeable. The rest, the higher numbers, not so much. You got 91, 92. But I would say that class B has two outliers. So maybe you can comment on that first. Outliers for class B. Sorry, we'll mention what they are first. 12 and 15, so you know what we're talking about. 12 and 15 in class B. Okay, now I don't have the calculation here, but if we actually took those out for the mean, you could see that, well, I'm only taking 27 marks out of the total. And so over 18 students, that's actually, about 1.5 marks to 2 marks difference. If I just ignored those 12 and the 15, the class average, or the mean, would be quite affected. So the outliers affected the mean, and if, like I said, if you took that out, I believe the calculation was the new mean would be 70. Could be off by a little bit there, but I think it's correct. Now, what about if you go back to this? If we took the 12, 15 out, how much, even if we changed it, if we bump these up to somewhere in the middle here, say this was a 55 and a 60, or even a little bit higher, that's actually not, it's not going to affect the median at all, as long as it's on the lower half, because where are we here? Yeah, those were the median marks. So if I just change some of these marks on this side, these middle marks would still be the same. So getting rid of outliers or changing them or have very little impact on the median and even on the mode. The mode is, unless you happen to have two outliers of the same value, which you probably wouldn't call them outliers at that point. So it has very little effect on the median. Okay, so that's how you would, first of all, let me zoom out a bit. That's how you calculate the marks. There, that's a better view. So again, sort all the data. You need that for the median and the mode. And then your different calculation techniques. The only real calculations are for mean and median. Mode, you just look for the most popular one, and you can see it quite easily if it's sorted. Mean is just adding everything up, dividing by how many you have. And median, well, there's potentially two calculations. One is to find the position in your list, and it could be one position or two. If it's two, you take the average of those two positions like we did for Class B, the two middle positions, 9 and 10. Take the average of those, add them together, divide by 2, we get 71. Whereas for Class A, there was 17 marks. 9 was the middle position, so we just use its value by itself. Okay, so let's continue on. This time we're going to be looking at weighted means. Weighted means. The personnel manager for gigantic marketing considers 5 criteria when interviewing a job applicant. The manager gives each applicant a score from 1 to 5 in each category. 5 is the highest, 1 is the lowest. Each category has a weighting between 1 and 3. Okay, so you can see got education, job experience, interpersonal communication skills, references. And for a particular applicant, this is the score they got out of 5. So obviously impressive on interpersonal communication skills. A little light on the job experience. So we're calling those scores X. Okay, now the company has decided some of these are more important than others. So the more important it is, the higher the weighting factor. So for example, interpersonal communication skills, they basically get a weighting factor of 3, which means these marks are 3 times more important than if it didn't have a weighting factor at all, like the references. So let's work with this. Just zoom in a little bit. Okay, so I'm going to do a couple things first because we're going to need it for part A. First thing we're going to do is add up the scores for this applicant, and I use my sigma notation for that. So it's just the sum of these, or in other words, use that sigma x. So the sum of these happens to be 20. The sum of the weighting factors we also have to add up, calling the weighting factor W. So the sum of W equals 11. And I'm going to add a new column here. So you can call it like weighted score. Weighted score. and basically we multiply the score with the weighting factor. So XW or WX doesn't really matter the order. We're just multiplying these two scores. So we get 4 times 2 is 8, 2 times 2 is 4, 3 times 5, 15, 15 again, and 4. And you can see which marks are going to help this candidate the most. It's the highest ones. And if we also sum that up, the sum of WX for this candidate is 46. So they want to know the weighted mean score for this job applicant. So this formula was on the first page. We didn't talk about it though. So in this case, we take the sum of the weighted scores, sum of WX, over the sum of W, the weights. Okay, notice we didn't use any of this. We just multiplied the score with the weighting factor, sum those up, and we take that total divided by the sum of the weights. So in this case, it was 46 over 11. So that gave this candidate a score of 4.2, and the company would compare that to other applicants, and the highest score means they're most likely to hire. Okay, second part, how does this weighted mean differ from the unweighted mean? So if we just found the regular mean, so unweighted, so in this case X bar would be, in this case, the sum of the scores, so the 20, just adding these all up and dividing by how many different scores there were. And we didn't use that at all in the weighted factor, so that would be over 5. So you basically find the average of these scores, and the average would be a 4. Okay, so you can see this applicant actually benefited from having the weighted scores compared to just an average of the different scores. So without the weighting, the applicant would have had a lower score. And you can kind of see why this applicant score went up when it was weighted, because luckily for that person, their highest score was also weighted the highest. So you can see we got a combined marks of 15 and 15 weighted compared to just using a score of 5. So that definitely helped. And then the last question, what do the weighting factors indicate about the company's hiring priorities? So what this means is the higher the weight, the more important something is. Okay, so the higher the weighting factor. So if we go back and look, so this company has a weight factor of 5 for interpersonal communication skills. So that's obviously the most important thing for them. So interpersonal and communication skills are very important. And if we go back and look for what's not important, the lowest weighting happens for references. So for this company, references are the least important or less important. So if somebody came in and got some scores and they did really well on references but not so well on these interpersonal communication skills, their weighted score would probably be less than their unweighted score. Okay, so that's the whole reason for doing weighted scores, is to prioritize certain of the data over other data. Okay, let's go to the next page. Happens to be the last page. So this time we're going to look at group data and how you work with group data for finding central tendency. So in this study, survey or experiment, we looked at chess games and how long we timed the different chess games and grouped the time it took into these time groups. So we had 2 chess games that were between 10 and 15 minutes. We had 20 chess games, 15 to 20 minutes, 18, 25 to 30 minutes, 10 from 25 to 30 minutes, and 5 from 30 to 35. Okay, so the reason why this is group data is because we have one column for this group, 10 to 15. You notice all the groups are basically 5, have a width of 5. And that's important. If you're going to do stats, the range of your groups have to be the same, otherwise the data will make no sense. Okay, if we didn't use groups, we'd probably have I have no idea, but we could have probably 25, could have up to 25 columns for times, and it just becomes less useful when you don't group it sometimes if you have limited data. So sometimes limited data you group it together so at least you can see the meaningfulness of the regions of the time it took. Okay, so first question, calculate, I guess we don't need a D there. Calculate the estimated mean, median, and mode times in minutes to complete a chess game. So before we do this, because these are different calculations than what we just did, I'm going to do a table. So start off with number of minutes, and then I'm going to have midpoint, so that's new. You may remember me using the midpoint during the first lesson when we did histograms of group data. So these are definitely related, what we're doing here, and that example we did in lesson 1. So we're going to call the midpoint little m, and then I have number of games, how many games were in a certain range of minutes. I'm going to call that f for frequency, and then I'm just going to multiply, just like we did with weighted data, multiply the number of games by the midpoint. Okay, so let me finish this chart off. So basically each one of these columns becomes a row here. So I'm going to have 1, 2, 3, 4, 5. Okay, so just to duplicate what I've got here, 10 to 15 is our first row, 15 to 20, to 20 to 25, 25 to 30, 30 to 35. So those are our 5 groups of ranges of times. And then the midpoint, we just take the value that's in the middle. So this is basically the midpoint is the average of the high and low end. So 10 plus 15 is 25, divided by 2 is 12.5. And you're going to see as the min and max goes up by 5, well, so does the midpoint. 17.5, 22.5, 27.5, 32.5. Those are the midpoints. You can see we need that because we're going to be using that midpoint when we get our last column here. And then the number of games, that comes from the second column here, second row. So I got 2, 20, 18, 10, and 5. Okay, so then I'm going to multiply the midpoint with the number of games. It's kind of like a weighted average almost, but not really. It's calculated the same way. 17.5 times 20, that's 350. we have 405, 275, and then the last one, 32.5 times 5 is 162.5. And then we're going to do a couple sums for these last two columns. Total number of games, if we add those up, I could say sum of F is equal to 55, and the sum of MF is equal to 1217.5. Okay, and now let's actually use this table to do our grouped central tendency. So I'll call it, everything will have grouped in front of it, so grouped mean. Okay, and still calling it X bar. So this time X bar is the sum of MF over the sum of F. So we've already got those totals, 1270.5 divided by 55. That is equal to 22.14 minutes. So that's our grouped mean. Then we're going to do our grouped median. Okay, now this one's a little different. It makes sense once you see how it's done. We know we have 55 games. So we calculate the position of the median the same way we did for the non-group data. So I'm going to do that position calculation here. It's going to be the exact same as what we did before. So this is like our n, number of data entries. So that's 55, and we add 1, n plus 1 over 2. So that's 56 over 2, so that's 28. So what we want to do is take the 28th from either end of the sorted data. Now, here's where the issue is. So we've got our data here, but they're grouped together. So I can't just start counting entries. But what I can do is say, okay, the first two, the lowest two are in this group, the next lowest 20 in this group. So I can actually start counting through these subtotals. So basically 22 would be, basically 3 to 22 would be in here, and then 23 up to, I think, 40 would be in here. Okay, so you're trying to find the 28th. So it's not in here because that's just the first two. It's not in here, that's only up to 22, but it is in here because the 28th sorted data would be there. So now, what time do I take for that? Well, this is where the midpoint comes in. I take the midpoint, which I've already calculated for that group, 25 to 30. The midpoint is 27.5. 27.5 minutes. Okay, so it's the same formula, but you have to apply it differently because you can't just count like we did on the non-group data. And then the grouped mode is another interesting one. Okay, so we'd look for, you could use this table if you want, which group had the biggest frequency, the most data. Well, that would be this group here, where we have 20. Okay, so what value can I use? Well, it's sort of the same as what we did with the median. We know our mode is in here, so we take the average of that group in terms of the time. So that would be 17.5. So first of all, it's the 15 to 20 minute mark, so it's 17.5 minutes. Okay, so there's our three values: 22.14 for the mean, 27.5 for the median, and 17.5 for the mode. Okay, and you can kind of tell the data is not exact here. So that's what we'll answer here. Describe potential issues with finding measures of central tendency of group data. So if I can just make the statement here, since group data uses the midpoint, of the interval, calculation will be less accurate. When the interval size is large. So what that means, like the interval size for our study here was 5 minutes. So it's not too bad. It's not a really wide range. So we take the average of it when we're doing our calculations. But what if the interval was, say, 100? So we take the interval that and use 50 as the score for that group. You can see the potential for problems when you do that, because data could be anywhere in the group, in the interval. Data could lie anywhere in the interval. So using midpoint could be inaccurate. Just 1 O. Could be inaccurate. And even for this example, okay, we've got, say, 20 games that were 15 to 20 minutes. So we're assuming they're evenly spread out, which is usually pretty safe. But what if all 20 of them were 15 and 16 minutes, and the rest of, there's nothing bigger than 16 minutes? I'm not saying it's true in this case, but it could be true. And we just made the assumption that the average of all 20 of those was 17.5, and in reality, they all could have been 16. So we're kind of making some assumptions about how spread out the data is, even within the group. So it's not as accurate as the non-group data. Okay, so the last part here, graph the data using a histogram. So from lesson 1, hopefully you remember. Now I'm going to do my 5 groups. So let me point out where those would be, 3, 4, 5. So this will be the chess game times in minutes. Okay, now this is where it's going to be different, this histogram, because we're using group data. So I'm not going to put like 5, 10, 15, 20. I'm actually going to put the ranges for each of these 5. So 10 to 15 here, 15 to 20, 20 to, sorry, I did that. Yeah, that's right. 20 to 25, 25 to 30, 30 to 35. So that's different right off the bat. And then I've got my frequency up here. So you can remember the highest frequency I had was 20. So let's do a 10 and a 20, 15, 5s. Okay, and this will be number of frequency. So game time and frequency are scales, axes. So 10 to 15. If you go back up here, we had 2. So 2 would take us about here. So I'm going to do my proper histogram where there's a gap between the bars. And then we had our highest value at 15 to 20. So all the way to the top. Then we had 18 for our next group. So that was a little bit lower. (25 to 30), we're back down to 10. and then all the way down to 5. So that's there. Okay, sorry about that. You can see it now. Now they also want us to put in, mark the measures of center tendency on the graph. So we know that if we go back to the data we calculated, the mean is 22.4, so that's within here. So I'm just going to write mean above there. The median was 27.5, so that's in this group here. And then the mode was 17.5, that's in obviously our most popular group. It has to be in there. So you can see all 3 of our central tendency measurements were in different groups, which seems a little bit odd, especially since there's only 5 groups. But that's the shortcomings of using group data, but sometimes it makes more sense when you have a wide range of values, but too many measurements. You don't want to, like I said before, you don't want to have a column for each separate minute, because the graph will be even more meaningless than this one. So, all right, so that's our lesson on central tendency. Our next lesson, we're looking at something called measures of spread. So now that you know how to measure the middle mark or the average mark, how do you know, how do you know how compact the data is? Is it all really tight to that mean or median, or is it really spread out? So that will be the second characteristic that we use to measure how the characteristic of the data you collected. And these 2 lessons, the one we just finished and the one we'll do next, are very important. We actually use them when we're in the last unit, when we talk about the normal distribution. We need to know things about the mean and the what we call the standard deviation we're going to be talking about in the next lesson. Okay, so again, as usual, got some homework questions to practice, and hopefully you have a better understanding of these measurements and how you calculate them. So until the next lesson, have a great day.